topic we want to cover today is the special angle relationship that exists when we have parallel lines cut by a transversal. But before getting into that, we want to review some definitions that you've learned in prior years. The first thing is, what is a right angle? It's an angle that measures 90 degrees. It's formed by a horizontal and a vertical line, and if the box is drawn, then you are told that that is a 90-degree angle. Or if you have two lines like L and M here, and the symbol, which is like an upside down T, is put, that symbol means that they are perpendicular. And perpendicular means that the lines form a right angle. Straight angle measures 180 degrees because it forms a straight line. If I were to make the arc for that angle, you'll see that it's a semicircle, and a circle is 360 degrees, semicircle is 180. Complementary angles are two or more angles whose sum measures 90 degrees. Okay? So as opposed to a right angle, which is just one, to be complementary, I need two or more. And then on the flip side, supplementary is two or more angles whose sum is 180 degrees. Now, students will regularly get complementary and supplementary mixed up. The way I've taught it is that they go in alphabetical order, C and S, and then in numerical order. I had a student mention today that the C you can make a 9 out of to make 90, and the S you can make an 8 out of for the 180. Whatever works for get you to remember. Vertical angles, oh, my pen's going a little kerflooey here, are a pair of opposite angles formed when lines intersect. Vertical angles are congruent to each other. So if you look at the diagram here on the right, I have a pair of intersecting lines. They form four angles. And we know that 1 is opposite 3, so they are vertical, and 2 is opposite 4, they are vertical. Should be a good 2. You'll notice that 1 and 2 form a straight line, as do 2 and 3, and 3 and 4, and 1 and 4. If I gave you one of these angle measures, so let's say 1 is 120 degrees, you can give me the other 3. 1 and 2 form a straight line. That means they total 180. That means 2 is 60. 1 and 3 are vertical, which means they are congruent to each other. They are 120. And 4, either by opposite or vertical to 2 or whatever. When you complete your circle, all 4 angle measures will total 360 degrees. Right? All right, now we want to get to angles and parallel lines. If you keep the following point in your mind, it'll be helpful. We just learned before that we have a technique to figure out what these 4 angle measures are if I give you one of them. That's what I just did on the previous page. What we are now trying to do is if I give you one of these angles at the top, we want to bridge to figure out what the other 4 at the bottom are. Or if I gave you one at the bottom, what all 4 are at the top. Since they are not next to each other, okay, or across from each other, we need some special rules. Now, the first thing, just a couple of things. M and N are parallel lines. The little arrow here tells us they're parallel to each other. Or the 2 lines slanted is the symbol for parallel. Okay? T, or the line T, is called a transversal. And a transversal is a line that intersects parallel lines at more than one point. Right now, you should be seeing that parallel lines cut by a transversal look very similar to like a street grid or railroad tracks or something, and that's what a lot of this is used for. Now, a couple of other definitions to just get out of the way. You're going to see the words interior and exterior quite a bit. Interior are the angles between the parallel lines. Exterior are the four angles outside of them. Okay? So, what we want to do is bridge from the top to the bottom. Now, before we do that, let's just go back to vertical angles. What we said before are they are a pair of angles, pair of opposite angles formed by intersecting lines. Okay? Now, we've already done this, but our four pair of vertical angles are 1 and 4, 2 and 3, 5 and 8, and 6 and 7. And as we've already said before, they are congruent. Okay. Now we want to get to some of the special rules. Corresponding angles. What the definition of a corresponding, and what we're going to do here is I'm going to give you definitions. I'm going to give you the angles that fall into the category, and then we're going to tell you what their measures are, the relationship between their measures. Corresponding angles are same side of the transversal, okay, what does same side of the transversal mean? 1, 3, 5, and 7 are on the same side as our 2, 4, 6, 8. That's all that means. They are same side of the transversal, one interior, one exterior. Okay? Now, what fits that? Again, I'm taking one from the top and one from the bottom. So if I start with angle 1, it's an exterior. Who's on the same side with it that's interior? 5. Now, somebody might say, well, what about angle 3? Well, we don't need special rules for 3 because we know 1 and 3 form a straight line. Now, who else? 3 and 7, 2 and 6, and 4 and 8. Each of these pairs are congruent to each other. Each angle within the pair is congruent to the other angle in the pair. Okay? Now, alternate interior. The word alternate means opposite sides. So they're on opposite sides of the transversal. And if they're interior, they're between the parallel lines. So what angles fit that bill? Well, there's 3, 4, 5, and 6 are the only interior. So who's on opposite sides? 3 and 6, 4 and 5. And again, 3 and 4 technically are on opposite sides, but we don't need a special rule for them because we know they form a straight line. Alternate interior are congruent to each other. Okay. Now, similarly, same side interior. Well, let's go to alternate interior. So you'll see alternate exterior. I'm sorry. Again, they are on opposite sides of the transversal because of the word alternate. and they are outside the parallel lines. Now, what angles fit that bill? Hopefully you're seeing that it's 1 and 8, 2 and 7. And these angles are also, each pair is congruent. So 1 is congruent to 8, 2 is congruent to 7. Now I'm going to go to the same side interior. Now, same side means that they're on the same side of the transversal. And they are on, if they're interior, they're between the parallel lines. Okay. What fits that? 3 and 5. And 4 and 6. These pair of angles are supplementary, meaning 3 and 5 add up to 180, as do 4 and 6. And then lastly, same side exterior, same side of the transversal, outside the parallel lines. Which ones fit that? 1 and 7, 2 and 8. And they are also supplementary. So if you are noticing, the only pairs that fit the supplementary definition are the ones that are labeled same side. So a trick to remember is same side supplementary, SSS. Now let's take a look at an example of this with numbers. What you will see is that once I give you one angle measure, like I do here, angle 1 is 100, you could find the other 7. Now the first 3 at the top, 2, 3, and 4, you don't need the special rules we just went through, because you know 1 and 4 are vertical, 1 and 2 form a straight line, which means they're supplementary, 2 and 3 are vertical. What we need the special rules for are to jump from the top down to the bottom. And you can use a number of different ways to do that. Some things you see much easier than others. So for example, 3 and 5 are same side interior. That means they're supplementary. That means 5 is 100. 1 and 5 are corresponding. That means they are congruent. 1 and 7 are same side exterior. They're complementary. Okay? 3 and 6 are alternate interior. Congruent. And 2 and 8 are same side exterior, supplementary. If you see, we have only 2 angle measures that are throughout this whole diagram, the 100 and the 80 degrees, and it's an alternating pattern. The top looks the same as the bottom, and you'll see the 100 and the 80 degrees keep alternating between themselves. Okay? All right. Now let's go down here. The angle up here is 152 degrees. Angle 1 is also 152 because they are vertical. 1 and 2 are same side interior. That means they add up to 180. 2 and 3 are vertical. That means they are congruent. 1 and 2 are alternate interior. That's false. 2 and 3 have equal measures. That's true. 1 and 3 are supplementary. That is also true. Okay? And then finally, if I tell you the measure of angle 1 is 62 degrees, you should see that 1 and 2 form a straight line. So that's 118. Now, the parallel lines are vertical. If it helps you to turn your paper to see them horizontally, that's fine. 1 and 3 are same side interior, supplementary. 3 and 4 are vertical, so they're congruent. So, to summarize, you need special rules to be able to bridge the gap between angles formed by parallel lines when the angles are not adjacent, meaning next to each other, or across, meaning vertical to each other. And you need to use the definitions that we've talked about to be able to do that.